the next section, we'll be talking about what are called as the observational and sampling approaches to creating SEGs. You may remember this slide from my previous lectures, and this is showing the exposure distribution for the overall general population, whether it's out in the community or in a workplace. And within this general population, there are subgroups. And in the occupational setting, we are calling these as our similarly exposed groups, or SEGs. So the purpose of the exposure assessment is to understand the exposure distribution, not only of the general population or the general population of workers in a workplace, but more importantly, the population subgroups, because that is where the risk management occurs. So we really need to understand the population subgroups. Another way of saying it is that we really need to understand both the between and within worker variability. As we have briefly discussed earlier, the classification of workers into SEGs facilitates efficient exposure assessment of large numbers of workers. The way we do it is, let's say an SEG has 20 workers all doing the same task or same set of tasks over a shift. We don't sample all 20 of them, but maybe we sample 2 or 3 of them several times. And from that set of measurements, we make inferences about the full population of 20 workers for the entire year or several years. By randomly sampling workers within each SEG, the exposure distribution of the SEG can be estimated. There are 2 primary reasons for variability of exposures in an SEG. One is within worker variability. This is the variability of the exposure of one worker obtained from repeated measurements over time. And when we do this, we are assuming that the work environment itself has not been subjected to any systematic changes. So by that, I mean that there has not been, for example, a new ventilation system that has been put in, or there has been no change in the production schedule, or the workers are not changing the rate of production. This variability, within worker variability, arises due to random variability in the workplace environment. So even though there is no systematic change, there is random variability in the environment. And so if you measure one worker over time, several times, then that worker's exposure changes from one day to the next or one shift to the next. The second type of variability is called between worker variability. These are variations in the mean exposures between individual workers that arise because there are differences between the workers in the way they perform their tasks and the differences in their work activity patterns. Between worker variability is not because of variations in the workplace environment, but variations in the workers themselves. One thing to keep in mind in all of these discussions is that we are only talking about one SEG. We are talking about workers who are all engaged in the same task or set of tasks or shift. We are not comparing workers who are doing completely different things. So even if you have workers who are engaged in the same set of tasks over a shift, or even just doing one task, there is within worker variability and between worker variability. So keeping this in mind, let's just discuss the first approach to creating SEGs. And this is called a prospective or observational approach. And this is based on an a priori understanding of the processes and tasks that each group of workers are engaged in. In 1979, Morton Korn and Nerton Esman described this and called it the observational approach. Here, workers are, before making any measurements, that's why the term prospective, they are grouped into exposure zones. That was the term used in the Korn and Esman paper. And this grouping is done on the basis of work similarity, meaning similar profiles of job tasks, similarity of hazardous agents, so the same chemicals to which they are exposed, and environmental similarity, meaning the workplace is similar, they have the same ventilation characteristics or processes and so on. The classification of workers into SEGs using this observational approach is subjective. The industrial hygienist or occupational hygienist observes workers doing different tasks with different chemicals and different types of environmental controls and decides that, okay, this group of workers are one SEG and this other group is a different SEG. And this relies heavily on the professional judgment of the occupational hygienist. Once these exposure zones, or what are called SEGs today, these are defined, a certain number of workers are selected in each zone or SEG for sampling. And an implicit assumption, a critical assumption, is that the workers within each such zone have similar exposure distributions. Not identical, but similar, meaning they form one log normal distribution. So each worker's exposure profile is very similar to every other worker's exposure profile, meaning each worker's exposure distribution is described by a log normal distribution, and the other workers also share the same log normal distribution with the same geometric mean and GSD, but maybe they don't have the same identical exposure, but they are coming from the same exposure distribution. So if in fact this is true, that all the workers share the same log normal distribution profile, then the only effective measure for reducing exposures are those that affect each worker in the group. And so there are no differences in the exposure profiles of the workers. So the only reason for variation is because the environment itself is varying. And so, for example, the ventilation controls might be randomly fluctuating from one day to the next, or the process itself has random fluctuations from one day to the next. While this is very intuitive and very easy to implement, the verification of this condition, the condition being all workers have the same exposure profile, the verification of this condition requires multiple measurements on each sampled worker in an SEG so that the exposure distribution of each worker can be individually determined and compared with the exposure distribution of other workers. Because that's the assumption here, that each worker has the same log normal distribution, and the only way you're going to generate each worker's log normal distribution is by measuring that person several times.